the
This
starting
conference
point.
will now be recorded.
So, this document was just a starting point, and I beg you to add your names to it if you add to it, and to add to it. And it may not even be the document we go with long term. It was just a starting point to open the discussions up and to do some initial alignments, and we've continued to take notes there. So feel free to add to it and to add your name and to make proposals in it. And what you can do is there's on the upper right, there's an editing mode button, and you can click suggesting if you want. And then when you make the suggestion, we'll see that it came from you, and then in the next meeting we can discuss whatever you wanted to add. And so Shen and Tony and Odie um, have been adding things and comments, and I really appreciate it. Um, and so, Yogesh, I had one of my topics today was I wanted to talk a little bit about the input to the analyzer, if that's okay.
That's fine, but maybe if is anyone familiar with the big picture, maybe worth
Oh, go over the
going
big picture. I'm sorry. Okay, I wasn't sure
real
what
quick.
you meant for it to go over right now. Yeah, yeah. So, I mean, let me pull up the goals. The goals, I think I wrote. Uh, okay. So, I've put together some time work on the goals, and um, the I think the goal is to provide better memory reliability through tools for gathering error logs, analyzing failures, and driving memory RAS actions. And um, implicit in gathering better memory error logs is uh, it enables better analysis than just counters. But it also enables sharing quality data in a consistent way with the memory vendors, and that means that whether Google or Microsoft or Meta or someone else gather the data, if we come up with some standards for how we gather the data and how we analyze it, any of us should be able to give you some error log data, and you can use the same tools to look at it. And I believe that the future of memory quality will require that. We have a bunch of 5-fit failure modes, and we need billions of device hours to see them. And so my thought is the more data we share over time, the better off you all are. So anyway, does the goal, and I'm saying it's to reduce machine downtime, reduce memory failures, and minimize their impact. Um, is this section of the document something we're aligned on? And I might move it up in the document if we are.
This is Roy. I want to add one more thing about the goal for this goal.
Absolutely. Please do.
Basically, as a DRAM vendor, the field data is very important. So the feedback to the DRAM vendor, field data to the DRAM vendor should be added. That is my recommendation.
Okay.
Kind of aligns with the bullet beforehand, right? Sharing quality data in a consistent way with memory vendors, silicon vendors, et cetera,
Yeah.
et cetera.
And to help improve quality, right? That's really why we want to do it. Did what I add reflect what you wanted, Roy?
Yes, to improve the DRAM process, or I cannot pick the right word at this time. I will read back to you later.
Well, actually, Roy, here's what I would
Yeah.
propose: is if you're willing, just go into the document and propose a change. What you can do is just enter suggesting mode, delete the word, and put the word you want, and that would be awesome.
Okay.
I welcome it. I beg you, please do it. That'd be awesome.
Oh,
Because
yeah.
we really need this
Yeah.
to be our effort, not something I'm doing.
Mm-hmm. But the reason I want to add this term is that when we think about the error log analyzer and the last action suggestion, the one in addition to that actions, we have to improve. We have to make some infrastructure to gather the error log itself, not the statistical data, not only the statistical data, but also we have to get the error logs as much as possible for the better quality
Yeah,
improvement. Yeah.
that makes perfect sense. So, and if there's something we need to add, please add it, or I'm willing to add it now if there's something you particularly want me to say. But yeah, I'm 100% aligned with you on that.
Hmm. Thank you.
Yeah, thank you. That was good feedback. Okay, well, I think what I'll do is I'll move these to the beginning of the document, just kind of at the beginning to say, hey, here's why we're doing this. And then, if someone has a concern or wants to tweak it, please just jump in and propose a change. But one of the things I wanted to make sure is like the output of the tools. I'm hoping will be, um, is this what action do we take, and is this particular DIM a risk of crashing the machine or a piece of memory? It may not be a DIM. Um, okay. Uh,
So,
so then, oh, go ahead.
yeah, this is Jordan from
Well,
Dell.
thank you, Jordan. Yeah, please.
Yeah. So one of the things that I think would be interesting is I recall a few years back, JEDEC had attempted to standardize error logging in the DIM SPD. I don't know if they actually ended up publishing that and fully standardizing it, but I think this is an opportunity for some good synergy where, obviously you can't fit quite as much information in an SPD as you could in a BMC or some other managing entity that's collecting just massive amounts of data. But there's some opportunity here to maybe get some boiled down data as an output of this effort here and storing that in the SPD. Does that make sense?
Yeah. Well, and I guess Jordan, just if you don't mind asking a question, I can't imagine storing every corrected error in SPD, but I could if I replace the DIM. Store the error that caused me to replace the DIM, or maybe like if it's an uncorrected error, was that? I'm just probing. I'm trying to
That
understand. I like what you're saying.
Uh, Jordan, I think that remember in the JEDEC 5, they have defined a section to store the error data in SPD, but that will be limited size, right? Yeah,
yeah
probably
yeah
I
yeah
think maybe more reasonable. We can define it's not might not be reasonable to store the raw data, but kind of a statistical data or the result from the analysis could be a better store in the SPD and bring to any memory vendor or OEM. Yeah, but I think at least the current JEDEC is not satisfied this goal. We can see how we can improve that. Right.
that's exactly what I was thinking. I didn't by any means say let's just go with the JEDEC, right? I think what we ought to do is continue the work here, and then as we're doing the
Right.
work here, think about what is a boiled down amount of information
Right. Yeah.
that we
Yeah,
can
we
use.
do thinking about getting JEDEC 6. Probably we need to getting some involved for the air log store in the SPD. Better utilize that. Not you
Yeah, that's
getting
right.
some
And then
Yeah,
format
go
static data that could be a good input. Right.
exactly, and then we go in and influence JEDEC to update their error logging standard, which I'm
yeah,
not even sure they published that, so
They have.
it may
They
not be
have.
hard to. Oh, they have
Yeah,
published it. Okay.
there's a version, but it's optional. So
Yeah,
the
it's
it,
defined, but
compliance is optional.
Well, and I guess the other thing I would say is if we really create a good path to send data back to the vendors, it might be that they have all the error logs for that part, or they can, like maybe if Google wasn't willing to share every bit of our memory data, we could make it so that if we return a a part to a vendor, that the vendor could query us for the data. And so maybe we might want to think about maybe also instead of statistics, just store the uncorrectable error if we had one, so that um, if someone's trying to do FA on the part, they can use the SPD to guide FA. So I think we'll have to figure that out. Like, is it more useful to have statistics and logs, or is it, is the last error log more appropriate for FA? And I don't honestly, I don't have an agenda here. I don't know the answer.
Yeah, I will say one thing, at least from the OEM perspective, maybe easier as a hyperscaler, but it's easy for us to lose track of system level logs to go along with the DIM. Whereas if you did an RMA on a DIM, the DIM suppliers have that on hand. So whatever data we can get
Yeah,
in there as breadcrumbs, um, to help them in case they don't have access to these kinds of logs, system level
yeah,
logs
and
would be good.
that makes perfect sense. I previously worked at one of your competitors, Jordan. It begins with an H. Yeah, I was the RAS lead there years ago, and so I get it. I know that it is hard to get the data back, especially customers don't always want to send it. And so that is where I think hyperscalers have a bit of an advantage since we own our fleets. We can get the data. So yeah, I think I'm very open to that. We just need to figure out what's most effective to gather.
Great.
Okay, that's a great
This,
suggestion. Thanks for bringing it up.
this is Jongmin from Samsung. I'm also supporting the idea that we need to propose error logging in the SPD information. So not only the UE information, yeah, there is kind of the booting failure. In the cases, sometimes the error logging in the SPD would be more beneficial compared to like the previous conventional error logging methodology. So also maybe probably we can save the information regarding how many HPPR is conducted in certain node and certain component and certain DIM. With that kind of information, maybe we can reduce the NTF rate.
Okay.
Mhm.
Jungmin, that sounds like a good proposal. I'm going to try to capture notes, but if I don't
Mhm.
get everything you said, please feel free to add. But 'cause I think you were
Okay.
saying, like you could capture HPPRs, right?
Mhm.
Was there something else
Capturing the
that?
HPPL, how many the repair scheme is conducted. So, you know, if there is HPPR conduction, yeah, there is some chance we could not duplicate the memory vendor cannot duplicate the failure in case of the low type failure. So if we
Yeah.
save the kind of information, how many HPPR is conducted for certain component and certain DIM, yeah, maybe
Okay.
we are able to capture and we don't need to put the resource duplicate the failure in the specific DIM. And the other advantage of the logging the information in SPD is that, for the map out issue or the booting failure, probably we need to know what type of the training making that kind of failure. Just hardware mem test failure or receive enabling command clock training failure. Booting failure, if it is not like the crack or hard type of failure, it's really difficult to duplicate for the memory vendor. However, if we save the information in the SPD, what type of training failure causing the booting failure, maybe we are able to more easily duplicate the failure and accelerate the failure.
Okay.
Mhm.
Yeah, that makes a great deal of sense. Yeah, and I guess the
Maybe I
if
can
we
add some more comment in the document later.
please do. Yeah,
Mhm.
I would
Okay.
welcome that. It would be great to get to great your input there. And I guess the other problem is that SPD is so small. If we have a
Yes.
compelling thing that we want to do with it, and we can
Mhm.
maybe make the benefit really clear, maybe we can
Mhm.
encourage increasing the
Mhm.
SPD size
So
to
Well,
actually,
accommodate.
we
memory
did.
vendor is just Samsung. Yeah, we 2 years ago we proposed what type of the main information would be needed for the SPD information, like the Jordan mentioned, like the UE information, and we also propose HPR count and something like the what type of last mode is activated, because we need to know about this each system specific last mode and stress load hole and the leaky bucket time interval to more understand what type of failure, what would be the more criteria for enabling certain last mode for the UE information UE teams.
Okay.
I
Okay.
think so. To answer Drew your question, we Dell actually did propose to the SPD to increase the SPD at JEDEC, and it seemed to have traction for growing it, but I think the error logging piece itself kind of lost traction. So then we ended up sort of backing off, pushing for it. So the point being is, if this starts to get more traction again, we can definitely go back and ask for a bigger SPD.
Okay. Yeah, so that would be great. And I guess, I mean, being Dell, you're probably sensitive to cost, the cost of, potential cost change. So, I'm hoping you can help us weigh the cost benefit, um, of doing
I
that.
was told at the time that it was fractions of a penny to increase it,
Oh,
but we'll see. We'll see. We'll see.
I guess when you're talking about a kilobyte, yeah, maybe
Right,
maybe so.
exactly.
Okay. Okay. Well, yeah, and I really like the idea of us capturing other opportunities. Um, so what I'll do is I'm going to make a section of the document with a heading, and and what I would encourage is for if you see other things that we can do while we're all gathered together, um, maybe put some in if you have other ideas. Sound good?
Yes.
Okay. Um, so then I'll move the kind of the goal to the beginning if we're aligned on it, and I welcome tweaking. I'm just driving a lot of this because I don't because I guess I just started something. But if someone else wants to drive some of this, I welcome it. Um, the other thing I wanted to ask you all about was uh, I was looking at the data that we feed the analyzer. And what I realized is that in some CPU vendors, and this is the error logging details, I guess, um, we need to think about how we configure the error logging registers to capture things. And um, I'm concerned in particular about any memory error log that we capture that allows overwriting. So, in other words, if I configure the memory controller to log um, the last error, I'm concerned that I can't read the errors atomically, or I may not be able to read the errors atomically. And if I can't, then that means the error can change out from under me. So, in other words, like I have to read, say 5 registers to log the memory error. And if I'm logging the last error, I could log the first register, another memory error occurs, and now the second register I read is from the second error. And then I go to read the third register, and another memory error has occurred in the meantime. And so, I have 5 registers. I could potentially get, worst case, error logs from 5 different memory errors. So I'd like to discuss, and I don't know if this is premature, maybe we need to talk about analysis more, but, uh, I'd like to discuss standards for what we collect. And, I'm concerned about overwrite rules. And the reason I'm concerned is, I've had suggestions that, hey, let's do the last error. And that might work if I also log the first error. And then I know the last error may be corrupted and it may be just opportunistic. But so collecting, first error is safe. Collecting may not be safe. And it could be, you could have a register. I could also imagine a scenario where, if I'm logging the last error, I had a bit I could set somewhere that says, hey, freeze the registers now. I'm reading them. And then we don't log any more memory errors while I read all 5 registers. And then when I'm done, I can clear it. And now we're logging errors again. So I just want to make sure that, whatever data we gather is done in a safe, expected way and with some standards. And I'm also wondering, do we care to distinguish between control scrub and demand scrub errors? And for me, as a hyperscaler, I kind of care because if it's patrol scrub, it's an error that basically I found watching my systems. If it's a demand scrub, it might be a failure a customer found running their workloads, and it might have affected them if it was, it turned out it was uncorrected. So, anyway, any feedback on what I've been saying so far? Are you all aligned with having to sort this out?
And Drew,
Yeah,
here is you're listening for the input for the analyzer, right?
That's right. And so, basically my assertion is that if the memory vendors do all this work to figure out, what a bunch of errors mean and what the scope of the damage is or the impact is to the DRAM, that we need to give them
Right.
consistent data.
Yeah.
yeah, yeah. Agreed on that, Drew. Um,
Regarding your statement on patrol scrub differentiation, there's another standard that we have that's similar to this RAS API that Dell helped in, and we did implement a filter essentially for patrol scrub versus demand read. So we're aligned that makes sense.
Okay.
and from a memory vendor perspective, we would want this information too.
Okay. That seems compelling then. But one memory vendor wants it. But is that controversial with you, Roy?
Definitely, I agree with you. Yeah, we need.
Okay. And Jongmin, what about Samsung? I mean, please speak up if this is controversial.
Uh,
Um,
I
Oh,
First of all, I would like to know the other memory vendors and like the Lois' opinion why we need to distinguish between the petrol and demand scrubbing error.
I'm sorry, I didn't quite follow that. Can you say it again, please?
I would like to know the reason why we need to define the petrol scrubbing and demand scrubbing error.
So, why? Um,
Mm,
for me, if I have a patrol, so we've discovered failures in our field with a patrol scrubber, or
mm,
failures in our data center, and it was pretty interesting. Um, the memory isn't all used, so there may be workloads that aren't touching all of memory, and so
mm,
if we find it with a patrol scrubber,
mm,
there's a higher chance we can offline the page, but it's also something we found that
mm,
uh, that if a customer is using memory heavily, the odds
mm,
are weighed in its favor that the demand scrub is uh, catching it. And so I can use that as a really rough proxy for which errors are being affecting customers versus which errors I know about but haven't necessarily hurt them yet. And I can use that as maybe information about how quickly I need to drain the machine or migrate a customer or offline a page.
Mm-hmm.
Did that
Okay.
answer your question?
Yeah, a little bit. So actually, yeah, demand scrubbing probably, yeah, we need to, yeah, the system CPU need to send some read command. However, in terms of the pattern scrubbing, yeah, it would be, yeah, proactively read and find the potential error in the memory before the CPU access the specific the faulty address. So probably it will be beneficial last feature, and maybe you can uh, well, like the data center and the OEM vendor, or probably use proper RAS activity for the potential error. Yeah, but I'm not 100% sure what would be really benefit for the address capturing for the petrol scrubbing and demand scrubbing. Yeah, just to gathering all the failure information. It will be just the region, I think.
Okay.
But as a memory vendor, SK Hynix really want to get the petrol scrub information, what or where the errors were from. The reason we strongly request those information is that when we are analyzing the error logs, the only way to remove the workload dependency of the DRAM access pattern, then the petrol scrub data is using the petrol scrub data is the only way. So if we want to see their workload, remove their workload dependency, right there, some specific area. Normally, some specific area is more frequently accessed when we are observing the DRAM devices. But when if we see the petrol scrub data, it is almost aligned with the DRAM DRAM architecture or something. So there is a very important information for us to analyze. So we are strongly suggest for SOC vendor to provide the petrol scrub information.
Okay.
Drew,
Thank you, Roy.
Drew, to answer your
Mhm.
question earlier, I think if there's any controversy, it's probably going to be on the SFC provider side, right? Whether they can output this data as part of the payload.
Yes. Well, and I guess the way I see it, Jordan, is that we're aligning on what we need. And, I guess I've always taken a really long, like a long view of working with the CPU vendors. So, if we tell them where we're heading and what we want and how we're going to use their processors, with enough notice, they can accommodate us. So, uh, even if they don't accommodate us right away, we will work our way there, is kind of what I'm anticipating. And I think if we build consensus, it makes it easier for the CPU vendors to accommodate us because we're aligning on requirements. We're not going to come up with conflicting things.
Yeah, that's fair. I'll say while we're on the topic of the patrol scrub, we need to be able to capture the ECS data from the DRAM. I don't know if it's already on your list somewhere.
Uh,
Uh,
it wasn't, but I've talked about it many times, so I should have had it. I agree with you. Yes.
ECS, and then whatever version, like when we get to DDR6, whatever DRAM related scrubbing information. Well, they'll probably name it ECS still, but whatever the successor is.
Yeah, hopefully it has more data. It's better. I'm not a fan of the ECS scheme. But memory vendors
Welcome
know
to
it.
the
I've
club.
yeah. So, and I don't think that's well, I mean, is that controversial among the memory vendors? I know that some of the memory vendors want the ECS data.
Yes. Yeah. Any additional data that we can get during an error is going to be useful. So yeah, the ECS information will be as unuseful as it is on DDR5. It will still be useful.
It's better than nothing. I agree with you there. I just hate the scheme.
Yeah.
Yes.
Yeah. Agreed.
Okay. And I think Roy, and Jungmin, what do you all think?
Samsung also absolutely need the ECS data.
Okay.
Thank you.
So it doesn't sound controversial. And I think Roy accidentally dropped. Um, is there someone else from SK Hynix? I mean, in the past when I've talked to you, I don't think it's been controversial about wanting ECS data, but I want to be super careful not to put words in your mouth. Oh, here's Roy. So Roy, I was just asking. Roy, I was just
Yeah,
asking. I'm pretty
I'm
sure
sorry.
SK Hynix.
I'm sorry, I was dropped. So, so could you repeat your question again?
Yeah, I think SK Hynix wants the ECS data too, right?
Oh, yeah, definitely. It's so important. We have when we are observing field data, the ECS data, uh, and in terms of the critical fault identification capability, using the ECS data, we can enhance the uh, identification capability. Yeah, so
Yeah.
we strongly want it.
Okay. It appears that it's not controversial. That pretty much all the memory vendors want it, and I agree with you. Uh, so I think we should say that's in scope for this effort is to figure out how to make sure we gather that data so that we can feed it to the analyzer. And is that controversial with the CPU folks? I don't think it's never been controversial when I've talked to y'all before, but I also don't want to put words in your mouth.
Hi, good morning, guys. This is Tommy from Intel. It's not controversial, and as I truly understand, the ECS data capture or readout is very, informative and important for the further, you know, uh,
Yeah.
that's analyzation though. And then so basically ECS operation itself is usually, uh, the CPU company is using the ECS for the, just only within the 24 hours, that just to cover the whole entire memory array. So that's a very infrequent, operation. And
Yeah.
yeah, so basically my question back to the, memory vendors is, when does CPU capture this ECS data? So basically, the certainly the CPU company can read out the basically the failure row address from the model register. So that is the basically model register read operation. However, ECS operation itself is very infrequent and spread over the 24 hours. And so my question is, so when is a good timing to read out the model registers, information? So for instance, so if we're gonna, intensive, model register reading, so basically, so that operation is gonna impact the, the performance itself. So, and so that's why basically, uh, we
Yeah.
it's a little bit harder to imagine. So when is the good time to read out the from the model register though?
Are you saying like read it every night at midnight or something, or have a particular time of day?
I think Drew, what Tommy is trying to get at, and I think we all probably have questions about that. What is the right frequency and what data should be how also part of it uh, delivered from ECS for it to be meaningful for debug, right? So
Yeah.
that's probably where we need to take the conversation.
Okay.
Yeah. Agreed. I mean, ideally, we would want it read at every error event. So every time you encountered a fault, capture the ECS register. But I know that that's unreasonable. Um, but if you were able to schedule it, schedule a read anytime, there was a fault, and then give it a long, frequency, like make it unnecessary to read again for an hour or something. That would probably be useful. Um, as far as just like intermittent polling, um, again, once every 24 hours is not frequent enough. But it doesn't need to be overly frequent. Um, again, maybe
Okay.
like once an hour would be useful.
Okay. Yeah, that
Tony,
seems
I had a question regarding that.
Hmm.
When I read the JEDEC spec, it seems that these are the results of this scrubbing or this ECS just get refreshed after a full cycle is completed. So even if we were to read it every error, you'll see exactly the same data until the full cycle of 24 hours has finished. So anything faster than the internal cycle for the DIM would prove no more data, I think.
That's my understanding. In automatic mode, it is on the full
So
cycle. You can go to like a manual mode where you can get
right.
it to go faster than
So
the I think 24 hours.
so after the reset, it will count up, right? So it will increment once it exceeds the threshold. So you will presumably, if you have a very large error that doesn't cause an uncorrectable fault, um, it will continue to count up, uh, as far as it can. Does that make sense? So it's doing a scrub, but it will incrementally get larger, and that's why it would be potentially useful to capture it over time.
I
So
see
it
what you're
gets
saying.
it gets refreshed, and that's the part I didn't understand. In the spec, I thought it was not going
It-
to be refreshed until a full cycle, and then it was like holding the value of the previous cycle until the full cycle is completed. But you're saying like we could reset it, or we could, because Jordan, I hear you, manual mode, but that's a big ask from us, right?
yeah,
So
no,
enabling
I would
manual
not.
mode, it's a completely different ask, and it's huge for us. But so in automatic mode, are you asking us to reset it after we read it, and then we count again,
Yes.
and then we have new counters? Oh, okay, I got it.
Yep.
You want to
Yep.
reset the scrub every time.
I think Carlos, did you want to say something?
No, I think I echo the concerns here. I think the asking for the ECS, some level of ECS information is not controversial. It's just the devil's in the details, right? And what is it that uh, will make it useful to report, right? If we're reporting stale data that it's not useful for the DIM vendors or the analyzer, then we would not go through that effort, right? So we have to go and define that as part of this effort and understand if you need it, let's say, for example, only on the UEs, things like that. I think we'll have to go into the details of it.
Let me. Uh, I'll take a stab at kind of spelling out um, what what I would envision, and then maybe we can go from there.
That sounds awesome, Tony. I'd love to have that from you, if that's okay with other memory vendors.
So
Phil?
Basically, so
along
for Intel, received the request from the SK Hynix. So basically, based on the one-on-one meetings so with Roy before, and so we found the ECS data capture at the CPU side. Basically, it's easy to use the read a model register read. So however, the Intel has not implemented so that feature yet. Basically ECS is just a ECS. So we basically in order to deliver the error data to the the memory vendors, so we have not captured the ECS data yet. So the reason why the we basically Intel has not had a good idea. So when is a good timing so to the capture the this ECS data though. Yeah, so that's why I brought my question, and it's yeah, I'm happy also to receive, the recommendations from the, DRAM vendors.
Okay.
Yeah,
Okay. Thank you, Tommy.
thank you.
So
Thank you very much.
is that okay? We'll start out with a proposal from Micron and then review it and
Yeah,
adjust if we need
sounds
to.
great.
Okay.
Yeah, that's fantastic.
I,
Thank you.
I would say that along since ECS is mode register data, I would ask that we also to consider, or at least based on what the DRAM suppliers think, is there any other mode registers that would be of interest to collect, since we're already in the topic of essentially collecting mode register data for ECS. As an example, is MR4 information relevant or interesting, or any other mode registers? That was just an example.
Uh, Hello, can you guys hear me?
Hey, Odie.
Yep.
Yeah, we can hear you.
Yeah, great question. And I brought this up to a lot of the module guys. We're interested in knowing more about the other active components on the module, such as the PMIC. And I've been told that there could be some PMIC related type information.
Yeah.
Yeah.
Any of the agreed? Any of the PMIC, especially the air flags. But there are a few different registers on the PMIC that would be useful to collect.
Okay.
I think
Yeah.
the thing about the other components, and I'm not saying I wholeheartedly agree that PMIX and other DIM components are probably of interest, but I think that they're probably a little less, not as high priority, simply because there is a pathway for the BMC to get to those through SM bus or I3C. So,
Well, and Jordan, I agree with you there, but I guess
Is Jordan breaking up for everyone?
no, I could hear it.
I'm sorry. Okay, sorry, then it must be me. Sorry.
So Jordan, one of the major premises I've been pushing is that we want hermetic error logs. In other words, joins are the root of all evil, and so I'm a little nervous about joining on the PMIC data on a timestamp with the ECS data. If we can build CPER logs that include everything, and so certainly the BMC, let's say we're pushing out of band error logging, it may be that, well, I know Dell may or may not be, Scott is interested, but um, what I've been thinking is I'd like the BMC to gather the CPU error registers, the ECS data, if there are any other mode registers, and PMIC information, put it all in a bundle and send it to the memory vendors. And the reason being is, if I have flaky DRAMs, but I have a PMIC error flag set, then I still probably want to replace the DIM, but I can pass that along to the memory vendor, and we can, drive quality improvements in the right place. So does that make
oh,
sense,
okay.
Jordan?
No, I do. I actually see now that the bullet is kind of more about this package rather than the API.
Yes, yes. I'm sorry I wasn't clear on that. It is more about the package. That's correct. Yeah.
Okay, yeah, then I withdraw. Yes, I agree wholeheartedly that the package should have the PMIC data.
Okay. Okay. Cool. I'm glad we're aligned. Go ahead, Tony.
Going back to Jordan's original question on other registers that would be interesting, we'll get a list. I can provide a short list of other things that would be interesting if they were able to be provided. A lot of them are
Okay.
going to be like DRAM training values that are set that don't necessarily have to be collected at the time of a fault or intermittently, but would be good to capture in a log.
Yeah, and I guess I can see that, maybe there's some training data or, non-error instance related data, but I'm simple-minded. I don't know. I want to think about how do we make it as self-contained as possible, or maybe we just have to have a kind of a boot time package that says here's how things were configured, here's how memory trained at the time boot time, and then
Yeah,
here's the error data. This is exactly the discussion I wanted to have with across the industry with all of you to um, kind of get alignment on how we do this. So this is an excellent discussion. This is exactly what I was hoping we would do. So thanks, Tony. And I
yep.
guess is there any concern with that? I mean, are we pretty aligned that ECS data, mode registers, and PMIX and other components like that are interesting? What's the buffer chip called? I'm drawing a blank on it.
The
The data
RCD,
buffer or the RCD?
The SPD hub?
The
yeah,
R, the
the
RCD.
register, yeah, RCD, their register. Yeah, there are
Uh,
flags in there as well. Yep, that would go along with the PMIC
okay.
kind of conversation.
Oh, I'm sorry, I put it in the wrong place. Yeah. Okay.
I guess if we're talking about this package, so to speak, we might as well include the temp sensor readings, because why not?
Yep.
Actually, I strongly agree. Um, I frequently hear, oh, you can just join it on timestamp, but that just makes things brittle. And then, if Dell collects temperatures in a different way than Google does, the joins don't look the same. So, well, my dream is that we agree on a package of data, and we can implement reference firmware that gathers it, and then feed that to the memory vendors. And I also imagine that as we discover um, what data is effective for finding failures, that what we want to collect will change, and that's fine too. And that's actually the beauty of CPR, is that it's easy to change. So I expect once we start providing data, the data we want will actually it'll grow in some cases, maybe in some cases, we find something's not useful and stop collecting it.
So onto this list then, I think probably interesting is also channel information, which channel it's plugged into, which socket, if it's multiple DIMMs per channel, which DIMM
Yeah,
socket
I
it's
think
in.
that's actually required. We require the channel address because ultimately we want the channel, bank group, bank rank, bank column, all that stuff. Because first of all, we got to figure out which fru is involved. So we need to know the chipset address of the error so we can convert that to some uh, a physical identity, something that matches the silk screening on our system. Now, that's not this analyzer's problem. I think this analyzer would tell us what's failed in terms of whatever the chipset numbering is, but then, like we each have to have a way to translate the chipset number to whatever we silk screen.
Yeah.
But I strongly agree with you.
Yeah, Drew, I had a question on the concept of joins. So the information we're putting there, they all have different time, let's call it time latencies. So for every correctable error, I cannot imagine to pull all of that information. So probably I'll have to pull for that on a regular basis. And then once you have an error, join it with that message and put it out. So we're always doing a join. It's who is doing the join, the difference, right?
Yeah.
Because
Well, the
temperature data is
join.
not going to be for every correctable error. I'm not going to read a temperature sensor.
When I say join, I mean outside the machine. If it's done in the machine, I'm okay with it, because then we're sending one error record out of the machine. And if I decide to run it through a new analyzer next week that is supposed to, be better, I can do that, and I can run the error logs back through it and see if the results improved. But the goal is ultimately hermetic error logs from the machine, and at least in my mind. Now, it may be that we have to split those into parts. Maybe and I'm open to debating that, but I guess I'd like to keep it as simple as I can for the analyzer and just say it gets a package of data and it analyzes the data and comes up with conclusions.
Okay. Yeah, because I mean, I want to leave the door open to do this in not only in the hardware, but in the driver. I understand the concept of a hermetic package, but perhaps the hardware is might be needing a little bit of help from a driver, but it'll be part of the solution. So through things like the other standardization we're working through,
Yes.
because if we're, for example, if I'm reading the ECS every hour, right? I don't want to necessarily store that and send it with every correctable error. I might send it to the driver and then have the driver make the hermetic message once it gets the other information. So I just don't want
Absolutely.
to nail this into the concept that the actual hardware will produce this hermetic log. We can have a mixture of hardware and driver because there are different time latencies on these things. So that flexibility will help as well.
100% agree with you. Yeah, and in fact, it's even more than that, Antonio. Let's say that we have a way to log errors from GPUs, and we have a way to log errors from the SoC, and we have a way to gather clock power thermal data from the machine. Each of those could be separate CPRA logs, but they would be joined by the software on the machine. So the machine would say, something happened. I'm going to go ask everyone in the machine if they had an error once someone notifies me they had an error. And if anyone had an error, I'm going to bundle it up in that bundle. And then, for this instance of an error, we have all the error logs from all the different things that we want to analyze. But I totally am aligned with you on it. May
Okay.
not be what gathers it.
Okay. Perfect. Perfect. Can do that. Yeah.
And a driver's no big deal. I mean, I think my goal is that when you go to Redfish, so here's my nightmare, and hopefully we can all align on preventing the nightmare. The nightmare is that we create a scattered set of redfish things that we have to go piece together to create what's going on the machine. That's my nightmare. My dream is that we have a hardware fault log and it contains references in its logs to all the things that generate a CPER. So you get this one message that says, I had an error, and you get a list of pointers to CPERs from all the different components of the system. And that is a complete picture of what we logged for the machine. And you don't have to grab
Uh,
anything else from the machine.
guys, this is
Yeah.
John Leon. I
Oh,
hate
looks like
to
we're
I
out
hate
of
to tell
time.
you this, but yeah, I've got the meeting after this, and they gave me the same bridge.
Okay, we'll drop. But thanks. We'll pick this discussion up next week then. And Tony, if you can come with some proposals, that would be. I welcome anyone, but Tony in particular, since you volunteered, that'd be awesome.
Will do.
Thanks, everybody. It was a great discussion today.
Yep, it was
Thanks
great.
all.
Hey, John, I'll leave the meeting, making you the honor if that works. Otherwise, you'll have
Okay, see y'all.
Thank you.
This conference will now be recorded.
Okay, thanks for those who made it. Figure out what I'm sharing here. Okay, this is a meeting of the profile work stream. This meeting will be recorded. Is there anyone who wants to make introductions of themselves? That's fine. Jeff Otter, who usually attends this, couldn't make it. He had a medical appointment that he had to get to. I think I fetched the two previous recordings and they're currently posted on the wiki. And that's the basically the process that we're going through. If anyone wants me to review that, I can go ahead and do that. So for IC pass downs, I have a link here which will take you to pass downs. Normally what I do here is go to rush to it. Is you have a running list of things that you need to know, what the upcoming events are. So the global, there's a China Day and then the Global Summit after that, and then the deadlines for this Global Summit. So most of the speakers have been notified of their sessions, and then the last is a running log of all the contributions which have been made at the IC meetings. So these are usually, by the time they get here, they're usually some time in ballot or review a ballot. So there's a running list of everything that's presented to the IC. You'll note, I would note that January 1st, hardware management seems to be pretty active at this point. We have DCSCM spec. We have 3 GPU specifications on manageability and RAS, and firmware update, all which are within the hardware management group, and server component resilience, which is also looking to get in the hardware group. So a lot of things are beginning to occur. Oh, and just last meeting, the OpenRMC users guide version 1.1 was presented to the IC, and so that's currently in review. So all that occurring within the host management group, hardware management group. It was decided we had to go spin off profiles as a separate work stream in order to get time to actually make progress on it. Any questions? Okay, so what I have today is, quick note is the profile update session was accepted into the Global Summit, so that would be part of the hardware track. And then the next 2 items is, if I have time, I'll get to the last item, is the pull request. So we went through most of the issues last time, and we currently have a pull request for the baseline profile. I'm gonna skip that because I don't think, unless anyone wants to go through it, it's usually Jeff and I going through the profile syntax. It's basically, it's a JSON file. And what we're trying to do is, there's an issue file that the baseline profile requires the thermal and power resources, and those were deprecated in favor of the thermal subsystem and the power subsystem resources. And so this is updating the profile so it will now accept both, whether the implementation accepts one or the other, with a notification that one is being deprecated when you run the test. So is there anyone who wants to go through the profiles? I mean, I can show it to you if you're interested. If you haven't read the profile spec, it's hard to understand exactly what the profile means. Okay. Okay. If no one wants to go through profiles, I'll wait until Jeff Outers is back online next month. Next item is the actual proposed Ethernet switch profile. So what I found with profiles is that everyone wants baseline's fine. We understand what it is. We did the server profile to highlight how servers are different than just a straight baseline. I think that's what we need to do to the other projects for them to get interested and start moving their manageability requirements above the profile. And so to that end, Jeff Catlin and I had a discussion about if we did for networking, what would we do? And we came up with a Ethernet switch profile. And so as the process states, we start with a user's guide, which basically describes the use cases and what we want to do with first with those use cases. And then once the user's guide is approved, and that's readily understandable without understanding profile syntax, then we would go on and create a profile which represents the switch, the user's guide. So let me go through that really quickly. And this uses all the standard formats of usage guides. So usage guides are set up so that there's a central table of capabilities, and then the capabilities has a link to each of the use cases of how you might do that and how you would do that in Redfish. So it's, everything's in the common creator. So this is a list of the capabilities. The first is the requirements that helps have changing everything. But basically, once you have a profile, you can actually run it using the Redfish profile validator, which is open source. Just point it to your conformant implementation, and it will go and run the test against it and gives you a output report. So the switch management profile extends the baseline. So you get everything from baseline in addition to anything incremental that you want to manage on a switch. And so there's a link here to the switch profile once it's been written. So now that we've talked about the baseline, here we go. This is what you get with the baseline. So you get hardware inventory, hardware location, status, power, temperature. This is all on a base chassis. Cooling information, log information, and management controller. Figure out if it has a BMC, what you can, the status of it, update get the version of the BMC. This doesn't have update yet. There hasn't been a request to update on the BMC for the baseline. There's a model of the bubble chart, and then this is the these are the incremental functions or use cases of the Ethernet switch. So I'll get a list of the switches because Redfish handles multiple switches. Get information on a particular switch, get the status of the switch, and then get the information so this is the physical switch itself. So this get the physical information on the switch chassis. Then the modules. So Jeff Catlin had the concept of a module. This is to get the list of modules which are on a switch, the supports, and then list the Ethernet connections. So this is both the interface, the list of interfaces, get any particular interface, and get the IPv4 address specifically. We can add IPv6 to that. Just need a comment to do that, and then to get the system log. So there seems to be a particular system log for networking that he wants to go get. So for each one of these, we point to a section. So if I go down to section 1, this tells you the Redfish command you would initiate, which would be to get fabrics, ID being Ethernet, and all the switches under the Ethernet fabric. And it will return you a list of switches which are ordered. And from here, you can now go get a switch. So if you're interested in a particular switch, you can go down and execute that switch access. So this is how you would get it. This would be Ethernet, switch ID, and then switch would be switch one. So when you execute that, you get this type of response. This is not the full return of a switch because it'd be much too large, but these are some of the information you can get about your switch. I should collapse this. So this actually gives you a status. So I think in the future, I'll just put this up here because you get your status. It's the same command of getting it. So this is actually packet into there, and I split it into two. And looking at it, I should probably split back into one. And this is to get the physical switch, which is the switch chassis. So in Redfish, there's a functional model and there's a hardware model, which represents the chassis itself. And this is all the information you can get from the chassis. For instance, it's a physical entity. It's got subordinate to the fabric adapters that might be plugged into the switch itself. And then a link to switch one. So this is a link to the functional part. So this is the physical part of the switch. It has a link to the functional part of this switch one, which is what we looked at above. And then this is getting a list of modules. So the modules are within chassis, and they're called network adapters. So this gives you a collection of all network adapters which are in switch one. And you can go get these the content of a particular network adapter. And this is the content that returns, which now points you to ports and also points you to network device functions. And this introduces an action that you can reset the actual module by executing a post to this path listed here, and we'll reset settings to default. You can get a list of ports by going down to this port resource. So this tells you how to get to the ports. So this gives you a link to the ports. So you can go down and look at the ports. You can now pick a port and download the information about that port. Again, this is just an enlightened copy of all the properties that would be returned in port. And then the same with Ethernet interfaces, which is why you would need network device functions. So for a network device function, you can have many types of functions. These are your Ethernet interface functions. So this tells you that there's two members, interface one and interface two, which are on a particular switch, on a particular network adapter, which has a particular network function. This has usually, if it's a network adapter, it only has one function. So, but this model also works for particular modules which have multiple functions on them. And so once you get down to the network switch, these are the information that would be provided to you. And right now, this is all read access, unless there's a specific request for write access. And so there's a write access as an example of setting address before. So what you get your IPv4 addresses and you set them as to your gateway. And then if you wish to actually set the IPv4 address, you do a post. You do a HTTP post command with the setting object. And that setting object is is shown here because when you set a property on a particular Ethernet switch, you want to sum all at the same time. You could post directly to the address property, but then these are in flux, right? They may or may not apply once you've changed your address. And so the way we set it up is that in those cases where you have to change multiple properties at the same time concurrently for it to be meaningful, you can use something called settings object, which is immediately below it, which is subordinate to the Ethernet switch. And you'll note here, it's under the Ethernet interface one settings object. And so once you do that, you can now do a post to this settings object, and it will set all four of these settings at the same time. I think that was the last use case. Oh, get switch logs. So switch logs are attached to the Ethernet switch itself, which is the functional side. So it has a log service. So you just do a get log service log. There can be multiple types of log service. I just call this log to make it simple. You could have security logs. You could have various different logs that are exposed. And by doing a get to log services, you get all the members, all the types of logs that are on the system. This fetches a particular one called log, and it has a set of entries, and those entries are listed below. And then, so now you can go get the individual entries. And then each entry has a particular format. So this is a cell log format, which those who know IPMI are familiar with. It has this, severity. It has when it was created. It has an entry code. It has a sensor type, a sensor number. And then it has a packed message ID, which is needed in IPMI, may not be needed in other message formats. One of the other message formats is SEPA, which is being talked about in the fault management group. And then there's an action here to do a post. So to clear the actual system log, and you merely do a post, I believe, in the log entry. Did I not put it? Oh, okay. There should have been an action tag underneath here, which tells you that there's an action. Because sometimes a system won't have an action to clear the log. Sometimes it will. When you get the log itself, it'll tell you how to clear the log if you're able to. And that's the way we've done. That's what Redfish has been done. So you always know when you get a response what you can and cannot do on the system. In this case, you can't clear a log. It should be listed as you do. It should tell you that you do a post to this particular path in order to clear the log, and you'll just get a 200 response if that's completed. Okay, so this is the initial draft of it. I'm gonna get comments from Jeff, who's worked with me on it, and then take it to the networking group to get them to move something above the baseline. Okay, with that, are there any questions? Okay, if there are no questions, then I am fine with, I've reached the end of my agenda. So if there's nothing else, and no comments, no questions, then I will close the meeting. Thank you for all those who attended. Oh,
Thanks, John.
Chris? Okay. Okay, thank you guys.
Thanks at the last minute. I'll join early next time.
Do you want to bring up anything, Mitch?
No. I'm gonna be representing Liquid more officially. So I'm just trying to get on the schedule of some key work groups, and this is one of them.
Okay, Liquid as far as liquid cooling?
Liquid LIQID, the company. we're
No, no,
we're
no.
fabricating.
I understand.
That's
Are
the
you
name of the
interested
company.
in are you
No,
interested in the liquid cooling profile?
no, we're interested in management of how the server is managed. So Liquid is a
Oh, okay.
composability software stack,
Ah, okay, okay.
right?
So
So
now
at
I
the
understand
bottom,
where you are. There's also a liquid cooling management work stream. We're just trying to figure out
right,
liquid
right.
cooling
This
stuff.
this is a company called LIQID, and we have a PCI Express product today, composable, built with out of a Broadcom switch, essentially.
Hmm.
And so there's and we have a software product named Matrix for composing and managing and orchestrating all these buzzwords for those systems. And so our software will call into this management stack eventually.
Okay. So have you looked into the composability model within Redfish?
Well, that's part of the task, is to come up to steam on where Redfish is and so on. Relatively familiar with, worked with Jeff Hillen and Jeff Otter for many years. So my task is sort of bringing Liquid up to steam on the Redfish model, and we're specifically focused on right now on CXL. And so but there's overlap in all of these, right? There's this management work group, there's the CXL management work group, there's the SNIA work group, so they're all overlapping.
Right, right. Well, I'm trying to understand how this work stream can help you, right? Because
Well,
we're down at the baseline, and we don't have a composability profile.
right, we're going to drive. We're going to. What my understanding is at this point is that our composability software stack and so on. It's a full application. We'll
Mhm.
call over Redfish, being Redfish compliant. We'll call down into this stack.
Okay.
Or there'll be a stack. There'll be a stack that conforms to this specification.
But
And that, yeah, go ahead.
okay. So I would say as you develop that, right?
Hmm.
If you find that you need uh, Redfish resources that are not listed here, right?
Right,
You should tell us, because
right,
then we could
right.
say, if you want to do a platform that can be integrated into some composability thing, right? We can go
Hmm.
write a composability profile to say,
Right,
right, for baseline systems, we need baseline plus these additional resources in order to fit you into
right, right. And
do
then
composability.
from a Liquid perspective, so I'm a hardware platform guy. I worked on ProLiant servers for 20 years, built them. That's how I know Jeff Otter and so on. But the Liquid's perspective is the hardware manufacturers are going to do whatever they need to do, and then they're going to surface their features through Redfish, right?
Hmm.
And so we don't want to we're not in the business of heavy-handedly asking the hardware suppliers for things, right? It's kind of a chicken and egg. Um,
Oh no,
they'll build what they want to, and with their feature set. But the main point is the common piece is the Redfish interface, right? And so, but
right.
then if we have a feature that we want, we'll work with them, as you're saying, and then we'll get that. I think you said profile, or used a term, but at any rate, we'll ask for that feature, and we'll agree on it, and then the spec or the standard, I guess, will then add that if it's required.
Oh, then I kind of need to explain to you why we have a profile
Okay,
in
profile, yeah,
OCP.
yes,
So the way I've taught DMTF and OCP is that the DMTF is a descriptive standard body. So the
hmm,
goal is to describe a standard. But
right,
most people look at it and says, this standard is getting bigger and bigger every week, right? How
hmm,
do I possibly,
right,
how do I actually implement all this stuff? And the answer is,
right,
it's not my job. It's a organization with what I call prescriptive power. that can decide. So just as in IPMI, it was big, and eventually I think DCMI came out and said, these are the only 20 commands you need. Don't worry about the rest, right? And then
Right.
the industry said, we could do that. Profiles do the same thing. It says, all right, Redfish is big, but in order for you to get OCP accepted or OCP inspired moniker on your platform, you need to conform to our profile. So, it's fine getting every groups to agree upon, but if you want that agreement to be almost codified so that all future people who build a product, right, say, I want to be, I have this baseline manageability, but I also want to fit into composability at some point in time, then
Right.
I need to go fit this composability profile. So you can, once that agreement, whatever agreement you make, right, you can kind of codify it here so
Right.
that at least OCP platforms will
Right.
make a decision whether they want to be composability ready.
Yep. So then from to distill that a little bit from our perspective, because we want to be supported on OCP platforms. So we'll have a layer that can speak to the OCP Redfish profile, and that's our goal. And we're not there's not too many demands on our end. In other words, our software folks say, just let them get it figured out and written down and the ink dried. And then the hardware guys, once they come back and they said, we support all of this profile, but by the way, there's this corner of the profile we don't do or something. And I'm making stuff up. And then we'll say, that's fine. We won't do those things. Right. Right. So that's kind of the way, right now it's very, and that's kind of the way the old DMTF and, manageability of the baseboard management controller, kind of how that worked. There was just a subset of the spec that kind of got implemented, and there had to be the tight agreement between the hardware supplier and the BMC folks to make sure that everything was done. But the protocol, I mean, the transport was from the spec, from the DMTF or whatever. So at any rate, we're hoping that gets a little more, that it's more defined. And my goal right now is to make sure that we're aware of what's going on in CXL, what's going on in OCP, what's going on over in PCI Express land and SNIA, and so on, and make sure that we're not missing anything. Because there's a lot of moving pieces, as you know. So anyway, I see this is all good. We certainly don't have a list of things that we're looking for right now. We're more grokking, consuming what you're doing, and understanding how we'll be compatible. Yeah.
Okay. Good.
Okay. Well, thanks. I'll try to make this call whenever it's on the calendar, and we officially,
once a month.
Yeah, I was joining as an individual because that was the best way. But Liquid has just recently become a community participant or member. So next time I'll join actually as Liquid.
Okay, great. Welcome on board.
Okay. All right. Thanks for your time today.
Okay.
Extending the meeting.
Bye.
All right.